Okay, so for today again, we're going to be looking at Chapter 6, Propositional Logic, and we're going to continue on. We've worked through 6.1 and 6.2. Waiting for it to load up here. And as we do, we've already gone through symbols in translation. Then we went through truth functions. And then now we're going to do truth tables for propositions. So we'll click on that. Okay. And we'll go through constructing truth tables and classifying propositions. So let's get this full screen. Okay. And so this will be the step-by-step method. Admittedly, this is where things will be getting tricky. You'll have to really keep in front of you the relationship in propositions when it's P and Q is true and Q is false. You'll have to remember that that's false, and so on down the line. Okay, so let's keep that in mind. 6.4, where we begin to test the validity of arguments, right? And then we begin to, and then at the end, last part, we will look at various ways of quickly ascertaining the validity of arguments. Okay, so we are now on 6.3. I'm flipping to it actually in the book. Right, it's truth table for propositions. If you look just at page 342, you'll see that the number, it's just in the middle of the page, they give you a formula that's going to sound difficult. The number of lines, see, that's L equals 2 to the n, and that's the only math you're going to have to do. But you can just look at that table because you're never going to get anything bigger than that. If you have one proposition, a simple proposition, you are going to have 2 lines. So for example, if you just have P, and P represents Peter is a good teacher, Peter is a bad teacher, whatever it says, hoping for you'll go good. You will have, for P simply, 2. And as we saw in the last chapter, if we combine 2 propositions into one, that is P and Q, we have to have 4 lines. If we have 3 different letters or propositions, we go to 8, 4, we get 16, 5, we get 32, 6, we get 64. So as you can gather, those are multiple, those are 2 to the nth power, but we won't bother to talk about the math much more than that. But the thing to understand is when you have a certain number of letters, you're going to need a certain number of lines. So if you look at the top of page 343, even though the formula is complicated, or at least looks that way right away, you only have 2 letters. And if we look back on 342, you see that 2 letters, 4 lines. We have 2 letters, 4 lines. Okay? And you see throughout that page, we just have 4 lines. If you turn to 344, right? Again, 2 letters, 4 lines, right? And then when you have 3 letters, that's when you get 8 lines, right? And so on, okay? So I don't think we'll have anything here bigger than 8 lines. That's quite a bit of work right there. But we're going to work through that right now, okay? So this section, as is said on the screen, presents an organized method for constructing truth tables. Truth tables were introduced in the previous section, as we saw, where they were used to define the logical operators, right? That is, we looked at whether P and Q, when they're combined, when they're true or false, right? We looked at if P then Q. We looked at P wedge Q, and we looked at P if and only if, or triple bar Q. So step 1 in constructing a truth table, or not a truth table, but a truth table, is to determine how many rows or lines we need, okay? And a row, of course, goes across, okay? This number is determined by the number of different letters in the proposition. So once you've taken a sentence and you've translated it, as you learned to do in 6.1, into a full proposition, right? Then you know the number. Just count the letters. That's essentially all we're doing. Okay? So you could have if P then Q in parentheses, then in another set of parentheses P and Q and parentheses, and that's still only 2 letters. So do not count the duplicates. Just look across, see how many different letters you see, and that's going to tell you the number of rows according to what's on the first page of the chapter. Okay? So we go from 2 to 4 to 8, 16, 32. Okay? Depending on how many different letters we have. Okay? So we have only one letter, one proposition. We're only going to have it being true or false. That's the only possibilities for one letter. But if we have 2, there's 4 possibilities. Okay? If we have 3, then there's 8 possibilities. If 4, there's 16 possibilities. 5 different letters, or 5 different propositions combined together. Or if a proposition has 3 letters, it's really one long proposition. When you combine all propositions into one, it's really now one long proposition. You need, if you have 5 different letters, you have 32 lines. When I first took logic, this was as long as it got. We never had to do 64. And we're actually going to learn a shortcut before the end of the chapter that never has you drawing out 32 lines. That's a bit sadistic when the logic professor does that to you, but it does happen. And I have done truth tables that long. I've done 64 lines, and so on. Okay? So that's how you determine the number of lines. And so if we were going to construct a truth table for A or not B, if all of that, then B. The number of different letters, of course, is 2. Just can't look across, right? A and B. So the number of different lines is just 4. That's it. Okay? So the second step is to divide the number of lines in half, which gives 2, right? Then go to the first letter on the left, and as I was starting to say last time, when you go to use the first letter, you go true, false, true, true, false, false. The next one is going to be boom, true, false, true, false. Okay? So you do 2 divided by 2 equals 1, right? So just to go back here, the second step, right? You take the number of lines, you divide it by 2, so then you know you go 2 and then 2, and then we divide again. 2 divided by 2 is 1, so you're dividing by 2. You're just trying to figure out how many truths to put before a false. It's hard to say out loud. So it's true, false, true, false. Okay? So now on the second letter, true, false, because we did 2 divided by 2 equals 1. You'll get used to this, and it'll go very fast. Okay? But basically, the first one you're always dividing in half, and then you're always going to, if it's 16 lines, you're going to have 8 truths, and then 8 false, and then the next one is going to be half of that, and the next one's going to be half of that, until you end up, the last letter is going to always be true, false, true, false. But since we only have 2, we move true, true, false, false, true, false, true, false. Now, so the arrangement of truth values covers all the possible combinations for A and B. And that's all that you're trying to do here, is cover all the possibilities. And that's what a truth table is. When we combine this together, what are all the truth possibilities? Okay? So what we do is we enter the duplicate columns under the duplicate letter. So you do the first time you see the letter first, and then you go over and you just repeat. What was B here? True. Then you just put true here. False. False here. True here. True here. False. And then false. And if there was another A, say over here, right? And this is like a parentheses, B and A, something like that. Then you would have true, true, false, false. A would always be the same. Okay? And the same for B, going down the line, going down the line. So you fill in under the letters first. Okay? And that's what they're calling duplicate columns, but we'll just say they're also the duplicate letters, right? So then you compute the truth values under the operators. Okay? Okay? And this is what we did in 6.2. So again, I used the cross-out method with my pencil. It's best to do this on a sheet of paper, right? Not, and we always start with the tilde or the not, the negation, right? We start in the parentheses as we learned in the last chapter. We don't go here first because we don't know yet what this truth value is. We have to figure out this truth value and then work our way out. So we cross this out. I just put a single line through it just so I don't get confused. And not true is false. Not false is true. Not true is false. And not false is true. I hope that makes sense, right? This was in 6.2, but it does bear repeating. I understand this is a chapter that really does build on previous knowledge, and Hurley's textbook in particular, I think, is actually pretty good with truth tables on building on that knowledge. I wish it was clearer in some of the ways that it discussed some of the language. I don't think it breaks down as simply as it could the language that it could use when you're, if you're reading it. To me, it can even sound complicated. Okay, so. But again, we start from the inside out. We have the parentheses. Let's just review this from 6.2, right? And so this was if A or not B, comma, then B. Okay? So we can imagine if either Adam is a good person or Brad is not a good person, parentheses, comma, then Brad is a good person. And so that's a sentence that I could make up out of this. Adam is my brother, and Brad is my son. So I'll be using those for A and B. But there, again, you see how this is just, the tilde is sort of the easiest operation. And then the next is going to be looking at this, where we compare just this or this. We forget about this now. We cross it out. Just a little line, just a little line on your sheet of paper, a little line on your sheet of paper, a little line, so you always know the one you're really dealing with. Okay? And then next, we compute the wedge, right? And this tells us the truth value, all the possible truth values, of what? A or not B. So we'll have the parentheses done when we fill in the yellow. And then we do, again, cross out here, 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 cross out here. Don't erase them or anything like that, because you might want to go back and see if you've made a mistake on one of the lines. So that's why I always just do a single sort of slash through. But you can, whatever method you need to use. I've seen people use, if there's 3 letters, they use, they use 3 different colored pencils. People use a number of different methods, but I think this is the easier way. It's just a simple cross through. Okay, so we know true or false is true. So again, go to the truth, the way those truth tables look on page, sorry, I just want to get that for you. So have that in front of you. The truth functions. This is a disjunction on 331 on the bottom. We know that P, if P is true and Q is true, then P or Q is true. If P is true and Q is false, then it's true. If it's false or true, then it's true. If it's false or false, then it's false, okay? So that's on page 331. Have that in front of you. I should also say it should be, we're going to be looking, if you go to the back of the book, just literally on the flap, you're going to see rules of application, rules of replacement. We're going to get to that. But if you see, want to see the truth table all in one form, just look at the first flap. Like literally just take the hardcover, pull it open, and look at the true, Q is true, 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 false, false. You'll see that it gives it to you for not P, for P and Q, P or Q, P horseshoe Q, P triple. Okay, and so all you have to do is go P is true and Q is true, and then walk over like you would with any chart to where it is. We're looking for the wedge, that's the OR charts, or the combined chart that's in the inside flat of the hardcover textbook. Okay? So now we're looking at if true, then true. So now if you go back to what the horseshoe does, right? Okay? So you're using only these columns. Okay? Use only those columns. And so now we can do a whole truth table for this whole, what looks like a relatively complicated proposition. And it is one, right? And then what we do is we take, these are all crossed out, and we use this column here, and we use this column here. Those are the only operators left. And the operator is the horseshoe. So if something is true, if true, then true is true. If true, then false is false. If false, then true is true. And if true, then false is false. And where do we get that? We get in the chart in the last chapter, right, where we have the horseshoe operator, right? And so just look for where there's true, then true is true. True, then false is false, right? You just look down the chart, or you'll have it memorized somewhat by the time you're done with the homework and by listening to the lectures. And then put in what are the possible truth values under the operator. Okay? So we get this final column here. So then what you do is you literally just take your pencil and make a square around it and outline the column under the main operator. Right? That is to indicate it represents the whole compound proposition. Okay? So we now can use this truth table to classify the proposition. Okay? So, if the column under the main operator is all true, the statement is to be said to be tautologous. What that means is it is always true. Okay? That's another way of saying that. So, tautologous means that in some sense self-references and cannot be anything but true. If they are all false, then it's self-contradictory. That is, a proposition is self-contradictory. And then if it's at least one time true, or at least one time false, it's called contingent, right? The statement itself is contingent, okay? So these are the different kinds of statements we can have. One where it's always true, tautologous, where it's always false, it's a self-contradictory proposition, and then where at least it's true or false, then depending on the conditions, it's contingent. That's all the contingent means. It's possibly true or it's possibly false. Okay? So returning to the truth table we have, we see what? I hate this figure here. It looks like from like a 1980s computer. So I guess it's kind of cute in its own way. A little throwback here for you. Now we see that it has at least one true and it has at least one false. And they're not all the same, not all true, and they're not all false. So therefore the statement is the third contingent. Okay? And again, we're just talking about what the statement type is. We'll be doing more work with this as we go along. So let's now practice what you've learned about constructing truth tables and construct a truth table for the statement given on your screen. Now we have how many letters? 2. And when we have 2 letters, we need 4 lines. Okay? That's on the first page of your chapter. So maybe keep that down, or perhaps write down or have next to you always how to construct the number of lines, and also that one part of the inside hardcover of the book where it tells you all the different possibilities of if P and Q, P and P horseshoe Q, P triple bar Q, and so on. So there are 2 different letters, and as we learned already, that gives us 4 different lines in a truth table. So where do you enter the first column of truth values? Click the letter in the proposition where this column goes. We move from left to right. Just as you write left to right, you start from left to right. Okay? So we'll start here. Right? We begin the letter farthest to the left. Okay? Now, we select the column of the truth values that goes under A. Now, since we have 4 rows we divide it by 2, and that's the number of the number of truths before we then turn to false, okay, down the line. If we had 8, we would go 4 truths. If we had 8 lines, we would go 4 truths and then 4 false, but it's always going to be divided in half. True, true, false, false. This you'll remember relatively quickly, I hope. Okay, true, true, false, false. Okay, so we could select this one. All right, you always begin by making half of the truth values true and the other half false. And if it's 8 lines again, then it's going to be 8 true all the way down, and then 8 false. If it's 16 lines, it's going to be 8 true and then 8 false. So next, where do we go? Well, we probably have to start with the B, because we can't figure out the tilde until we figured out the B. So let's go to the right. We go to the next column under the next different letter from the left. We always work from left to right, but we can't figure out this tilde without going here first. And as we learned, we now go, we had 4 divided by 2, gives us 2, and then we go now have 2 divided by 2 is 1. It's just going to be true, false, okay? Gets a little more complicated when we have 8 or 16, but we'll get to that. But for right now, it's true, true, false, false, true, false, okay? So let's see, this is true, false. For the last different letter, okay, and we only have 2, so that's what makes it easier. But for the last one, right, it's always true, false. So for the last letter that you have, and this is the last letter, these are going to be repeats of what we have. So where do we enter the next column or columns? Do we enter under the dot? No. Do we enter under the dot on the left? No. Do we do the wedge? No. We've actually made it easy, right? We put the truth values by duplicating the letters. So this is true, false, and then A was going to be true, false, just as we have here, right? It's just copying over, it's just copying over A, and it's copying over the B. Okay, so you get all the truth values put down first for the letters, and then we start to move for the operators. Okay? So, which column next? Well, I like to go from left to right, but in order to figure out from the parentheses, we have to then first do the tilde. We have to figure out what not B is. Okay? So we do the tilde first, because we're working with this set of parentheses. So not B is not true, is false. Not false is true. Not true is false. Not false is true. So we have false, true, false, true. And when you do these enough times, actually, you almost won't even have to do the work. You'll see not B, oh, not false, true, right? And that's it, right? So the column is the tilde, exactly the opposite of column B. Okay? So which one do we do next? Well, we could do the next tilde, but we're moving from left to right. So we're still in the parentheses here, so we're going to do the and. Okay? Right? You enter the column for the dot inside the parentheses. Again, always working from left to right first. Work within these parentheses, get that done. Work through the other set of parentheses, get that done. And then work through the main operator and get that done. Okay? So under the dot, we have true and false. Remember, we're supposed to cross these out a little bit. They could have worked with different letters, to highlight these for you. But in any event, true and false is what? False. True and true is true. False and false is false. False and true is still false. Right? So this is the only line where it's true. Right? So let's see where we have one where that second line is the only one true, and there it is. Okay? And again, that's just by looking at the different lines on the first page of 6.2. It's actually the second page of that chapter, where you see that if one is true and one is false, then it's false. If one is true and the other is true, it's true, right? That's the only time it's true. So this and is easy to remember because it's only true in one time when both sides of this part of the proposition are true, and so this would be false, true, false, false. Okay. All right. So which column should we enter next? Well, we can't do the main one, right? Because we have to work outside of the parentheses. But we can't work outside of the parentheses without doing the not or the tilde next. So let's do that, right? You enter the one for the column next, okay? So what is not true? It's false. What is not true is false. What is not false is true. And what is not false is true. So it's going to be false, false, true, true. Let's see which one is that. False, false, true, true. And there we go. Okay. So it's exactly the opposite of column A, under column A. So which should we do next? Let's click on the one that we have to do next. Well, we still haven't gotten out of these parentheses yet, right? You always have to work inside the parentheses before you can get to the main operator, right? How would you compute this? You don't have the main final answer. So we have the sort of final answer for this one, all the truth values for this one. We have not yet, though, the final truth value for this, the major operator in the parentheses. That's what we're looking for. This is the major operator here. This is the major operator here. Figure that out. Then we get the final operator, and we get the truth value for that. So let's do the wedge, right? And so true or false, right, gives us true. False or false gives us false. True or true gives us true. And false or true gives us true. Okay? So remember, with the wedge, or the or, right, it only has to be true for one of them for it to be true. And the only line that is false is when they're both false. Okay? So remember way back when either Boston is in Europe or Atlanta is in Canada is the only time that or would be false. Every other time it's true. Either Boston is in the United States or Atlanta is not in the United States, I guess, is false, right? And so that's still true because Boston is indeed in the U.S. So we have true or false is true, true, false, true, and true. So true, false, true, true, and there we go. Okay. And so now we have the final dot, okay? And these are the two that we're looking at. These are the two final operators that we have, right? So false and true gives you what? False. True and false gives you false. False and true gives you false. And then we get false and false. True gives you false. So this is going to be a column of all falses, right? And that, as we've learned, is, right, we put a big square around that, right? So it represents because it represents the entire proposition. And as we know, all false is self-contradictory. Okay? All the truth values under the main operator are false, so the proposition is self-contradictory. Clicking OK. So let's do some practice problems with that ugly-looking rat. So let's construct the truth table for this proposition. So how many lines do we need? We have how many letters? 1. So how many lines must we have? Well, A can be true or false. That's it. Boom, 2. Okay? And so, with the first one, A, it can be either true or false. There's nothing else that A can be. It's not complicated. This is one of our least complicated truth tables that we'll do. Even though we have a tilde, even though we have a conditional, this proposition, because it has only one letter, A can be either true or false. And since we don't have any other letters, we don't have to have all those different combinations of possibilities. Right? So under A, we're going to put true or false. And then we're going to duplicate that for each of the A's. Okay, true, false, true, false. We're then going to have to then do what? Well, we work with what's in the parentheses first, right? So when we enter the columns for the operators, then we click the 3 operators in the order in which the columns should appear. So we're going to do the tilde first, then we figure out the horseshoe, or the conditional, and then we figure out the main operator, right? It's the triple bar, right? And so it's true, true, and so this is tautologous, right? That's when all of those are true. Right? But always put that square around when you finally got to the main operator. So that's tautologous. Okay? All the truth values under the main operator are true, so the proposition is tautologous. Okay? Okay? So now we have, let's look across, K, S, K, N. Now we're getting into a more complicated one, because how many letters do we have? 1, 2, I've seen this one before, 3. So 3 letters gives us not 2 lines, which is 1 letter, not 4 lines, which is 2 letters, but 8 letters. Okay? Again, this is on the first page of the chapter, where it tells you how many different letters do you have, and how many lines do you have. Okay? 3 lines gives you 8. So you don't have to memorize anything. Again, when you're doing the examinations and so on, you will have the book with you to look this up. My hope is, though, that you begin to memorize these before, as you do them, because looking back at your book again and again, you're going to end up memorizing them when you do the problems in any case. Okay? So this says, select the column of the truth values that go under K. And remember, K is here. We take the number of lines, which is 8, and we divide by 2. And that tells us how many trues before we go to all the false. So it's going to be true, 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 false, 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 right? So it's going to be 4 and then 4. 4 true, then 4 false. Okay, that's the first letter. Okay? And then for the next one, for the S, right, because we move from left to right, we divide by 2 again. And it's going to be true, true, false, false, true, true, false, false. So we do, here we've got 8 divided by 2 is 4. Then we divide by 4, then we have 4. 4 divided by 2 gives us 2 truths, then false, then 2 truths, then 2 false. And then we get to the next one, it's going to be true, false, true, false. 2 divided by 2 equals 1. Okay? So this is going to be true, true, false, false, all the way down. Okay? So the truth values for the second letter alternate twice as often as they do for the first letter. Okay? Which is a rather complicated way of saying just divide by 2. Right? True, 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 true. Then the next one is going to be true, true, false, false. See, 4, then 2, and then it's going to be 1 true, then false, then 1 true, then false. Okay? So now let's figure out that N. We've already said it. It's the last letter. And when it's your last letter, you don't even have to think about it. It's true, false, true, false, true, false. Whenever it's your last letter. Okay? They alternate every line. Okay? And so then what we do is we duplicate the line under the K. And so we take this and we just repeat it. So next, we enter the columns for the operators. So we click the 4 operators. So what we'll do here is click the 4 operators in the order in which the columns should appear. So we always go to the tilde first, even though we're moving from left to right. It might actually bounce me and say I should do this first. So just because it'll bounce me, but I always like to do the tilde first. But we'll do this, since we're moving from left to right, we'll take care of this parentheses first. Then we go to we can't do the main operator, because we need to figure this parentheses out. Well, we go to the tilde next, not true is false, not true is false, not true is false, not true is false, not false is true, not false is true, not false is true, not false is true. Right? So you can see that this is the main operator we're going to be using here, in those parentheses, and then we do the wedge. False or true is what? True. False or false is false. False or true is false. False or false is false. True or true is true. True or false is true. True or true is true. And true or false is true. And so that's what we're going to see when we click the wedge, right? All the way down. It turns out I'm correct. And so what we're going to be working with is comparing these under the main operators in the parentheses. So if they used a little different language in the book, I'll say the main in parentheses, the main in the parentheses, and then we do the final operator which is here, right? And so true and true is true, true and false is false, true and true is true, true and false is true, true and true is true, true and true is true, false and true, it has at least one false, is false, false and true is false. So there we go. Boom. All right, and then it fills it in nicely for you. Then we're going to want to obviously highlight it. We outline that one because it's the final column under the main operator. And so we know that if we have at least one true and at least one false, we're already contingent. We know this by the second line. It's called contingent. They're not all true, as tautologous. They're not all false, which is self-contradictory. We just have contingent. So now we're going to be comparing propositions. So comparing one proposition with one another. Okay? So compare these two propositions, right? So we construct a truth table for each of them. K and L is 2. That means we're going to have 4 lines. The first one is going to be true, true, false, false. We're going to have true, false, true, false. And then the horseshoe is going to be true, false, true, true. Right? If true, then true is true. True, then false is false. If false, then true is true. If false, then false is true as well. So we know this from 6.2. And then from here, we have a little bit more of a complicated one, right? Because we have to do the tildes first. We have not true is false, not false is true, not true is false, not false is true. We go next and do this tilde. So I wish they gave us a little bit more time to build this up. Not true is false, not true is false. Not false is true, not false is true. Then we X those out. X those out. And so if false, then false is true. If true, then false is false. If false, then true is true. And if true, then true is true. And again, you just go back to the truth tables that are given to you either in the right inside flap of your hardcover on the first soft page, or on the second and third pages of 6.2. Okay, so we compare these two propositions. So this is what we're going to be looking at, these final operators. Okay, so these are not completely separate truth tables. Identical letters must have identical columns of truth values. So the L's are going to be the same, and the K's are going to be the same. So note under the column, as it says, L in the second truth table, it's identical under the L in the first truth table. The same goes for the column under K. So when we're doing comparisons, we're going to leave this wide space open. We'll do the 4 lines because we have 2 letters, but we're going to go across in the same way, but leave the space open, okay? Because we want to compare them, in the same way. We're not constructing a totally different truth table here. Okay, so just leave this space open here because that's our space where we're going to have something of comparison. So we outline, of course, at the end, what we're going to be comparing, right? That is the main operators. So comparing the columns under the main operators, you'll see that they are identical, right? True and true, false and false, true and true and true and true. This means that the two propositions are logically equivalent. They never necessarily have the same truth value. That's all that means, right? So when they are equal, they are logically equivalent. So if K then L is logically equivalent to not L then not K. And if you took algebra, you learned this probably as the law of the contrapositive. Okay? We will come to this later, but you've actually now proven that these are identical, right? If you go to the back flap, right, you'll see that under the rules of replacement, right, this is one of those, it's going to be one of those rules. Okay? Okay, so let's, again, this is what the law of the contrapositive as you learned it in algebra. If you took algebra, you don't have to have taken it. I'm just saying it's been done before. So there are 4 possible relationships between two propositions. The propositions could be either logically equivalent or they could be contradictory. That's where they're the opposite. And if neither of these apply, that is, they're not just the opposite of each other, and that then they're either consistent or inconsistent. So we have 4 possible ones. So when the truth values on each line are the same, that's what TB means there, they are logically equivalent, okay, as we saw in the last one. If there's an opposite truth value on each line, then it's contradictory. If there's a line on which both are true, just one of them, then it's called consistent. And if there's no line on which both are true, then it's inconsistent. So you just need both to be true at least once to get inconsistent, and then if there's no line on which both are true, then they are inconsistent propositions. Okay? But what's important for us is really when they are logically equivalent. Okay? That'll be more important later on. So again, this is just telling you what we've already said. If they're opposite, they are contradictory, and so on. If there's at least one line where it's true, so on, then it's consistent. If there's no line on which they're both true. That literally means on that line, it's T and T over here. If there's no line on which it's T and then T, then they are inconsistent. And if there's one where they are true and true, then they are consistent. Okay, but these are the 4 possible relations. Now let's practice what we've learned. Okay. First, you construct the truth table. Right. So to save you time, we'll just do this quickly. Right. That is, we're going to have, but it's good to always review. We have for here, if P then R is going to be true, true, false, false. We have 2 letters over here. So we're going, if we had 3 different letters across, which you're not going to have when you're doing a comparison, but you could, but there would have to be 3 letters here and 3 letters there. If we have if true, then true is true. If true, then false is false. If false, then true is true. If false, then false is true. This is the quick horseshoe diagram. So for the proposition on the right, let's select the column of the truth values that go under R. Right? So the R is going to be the same as the R over here. True, false, true, false. Right? It's just the same. We just keep going across. Again, we're just leaving the space in the middle undone for comparison. So next we complete the truth table for the proposition on the right. To save time, they're going to just do it for us. Great, so it's nice when they solve it for you. Not false is you're going to start here. We've already answered this one, so we put a square, a rectangle around it. But just to review a little bit, we start with the tilde, and then we go to the and, or the dot, and not true is false, not false is true, not true is false, not false is true. So false and true is false, true and true is true, false and false is false, true and false is false. And now what we're going to do is compare this column to this column to see, is the proposition, are they equivalent? Are they contradictory? Are they consistent? Or are they inconsistent? Okay? So are they the same? No, already on the first line we see that they're different. This is the opposite. False and true is the opposite. True and false is the opposite. True and false is the opposite. So we know that they are contradictory. Right? Okay? The truth under the values under the main operators are literally the opposite on each line, and that is contradictory. So we have the rat back, which tells us that we're doing some practice problems. So let's compare these 2 propositions. Okay? And we're going to have how many lines? We have 1 letter, we have a B, we have an N and a K, so that's 3. Do we see any other letters? No. So 3 letters, 2 letters gives us 4, 3 letters gives us 8. So we have 8 lines, and the nice thing at this part of the chapter, at least, is that this will fill it in for me. Okay, but notice the order. If I slowed that down, where we went, and I want to talk about that for a second. Okay, so we start with the first letter, B, and that's going to be 8 lines. do the truth values under there. And we're going to divide by 2. So here we had 4. Now we're going to go divide by 2. 2 divided by 2 is 1. So we go true, false, true, false, true, false, true, false, true, false. And then we solve the parentheses. And true, true, false or true is true, false or false is false. So now that we have all of that, we can do it true and just look at this column. False, false and true is false, false and true is false, false and true is false, false and false is false. If I'm taking up time doing that, I just want to, again, we'll keep going. Now what we do is, for the truth table on the right, select the column of the truth values that goes under K. The K over here. Remember, it's got to be the same. It's got to be true, false, true, false, true, false. It's got to be the same. We're going across as if it's one, well, it is. It's one table, except we're leaving a space. When we get to arguments in the next section, you'll see that they are connected, and then you go across. But here they're disconnected, and we're comparing them. So it's true, false, true, false, true, false. I think that's the one. Yep. So the column under the K must be the same as the column under the K before. Okay. And the same thing of that of the B. Has to be true, 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 false, 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 false. So carry that over. I think that's this one. Yep. Okay. And the same thing for B again. And then for N, we do the same thing. Okay. And now what it's doing is what? Working its way out. We start with the parentheses, right? And we go if K, because we've already solved this, and we have our rectangle circling the rectangle highlighting what is the final operator here. And we're going to need to get to this final operator. So we start with the parentheses from left to right. K horseshoe B. If true, then true is true. If false, then true is true. If true, then true is true. If false, then true is true. If true, then false is false. If false, then true is false, then false is true. If true, then false is false. If false, then false is true. Leave this alone. Then we do the tilde and go all the way down. Not true is false, etc. Then we do if true, then false gives you false. If true, then false gives you false. If true, then true, and so on. So we get this main operator. Then we go from true and false gives you false. True and false gives you false. True and true gives you true. True and true gives you true, and so on and so on. Going all the way down the line. So they've solved it for you. And so now we have to compare the truth values of these final operators, that is, for these different propositions or statements. Okay? So we have true, false, true, false, true, true. Right? So now they're not all opposites, so they're not contradictory. They're not the same all the time, so they're not tautologous. So we now need to know whether they're consistent. And we've already found a line where both are true. And so we're going to know they're consistent or inconsistent. We've already found one. It's going to be a consistent one, not inconsistent. But I'm moving ahead. So it's not logically equivalent. It's not contradictory. It's consistent because we have at least one line where both sides are true. Do we have any others? No, just one line. Okay? So it's consistent. So at this point, you should have no problems, hopefully, working through the exercises in your textbook. Okay? Again, as I keep saying, always come to me. I'm always seeming to plead here, but come to me and ask me if you have any questions, if you want to do truth tables together, if you are not understanding anything. I think it's helpful, even if we have to do it virtually, that is, I can do this from home on any day of the week. You'll have to just see a non-working fireplace behind me, perhaps coffee cups or whatever, but I'm always happy to Skype you or FaceTime you or whatever, to have virtual office hours or to have official office hours during the week as listed on the syllabus, or any other way that we need to get together to discuss this. There are extra problems and so on that are given to you at the beginning of when I first put up chapter 6, I put a number of different exercises that you can use throughout the chapter to help you. Okay? I'm trying as best I can to give you helpful hints. So let's exit. All right. But for now, I wish you good luck in doing your homework. And there we are. Thank you very much.